Welcome to episode 2 of the full project residential series that we're doing here on Electric Rob channel. We're going to be covering things like adding room names to your project and some of the pitfalls you may fall into with the room tag issue. We're going to look at downloading some content from Autodesk's cloud. We'll look at placing receptacles, assigning loads to receptacles. We'll change the scale of our drawing. We will get the mounting heights set for these receptacles and associated with different levels of our building. So stay tuned for an in-depth electrical video. If at any time you feel like you're getting something out of this, go ahead and please hit that like down below to share it with other people. And if you want to stick around for the full series, go ahead and hit that subscribe button. Sure appreciate it. And appreciate any of your comments and feedback. And thank you to those of you that have already subscribed. And let's get right into it. So here we are in our residential tutorial project, and I'm on first floor plan power. I plan to put in some room names. Now, how do we get room names into this thing? We don't want to just type text if we don't have to. We'd like to use the built-in room tag tool in Revit. So up here under annotate, we go to room tag. This may seem like a very straightforward, simple thing to do, but sometimes you'll run into roadblocks, and I'm glad we will on this one so we can show you how to deal with them. Nothing like the simplest things driving you nuts. So here we go. Room tag. First of all, rooms are not currently visible in this view. A view template is assigned to the view. In order to make rooms available, the view template needs to be edited or removed. So by default, our view template did not have rooms turned on, which are a physical entity in Revit. So we need to manage our template and get those rooms turned on. And they mean in our model. So we're going to go to our model here, not the Revit link, our model, edit that. And we're going to go down to, it's actually a model category. It's a 3D piece. Down here under rooms, and we can see that rooms is not turned on. We're going to enable rooms. Okay. There. Now we have rooms enabled. Now we go to room tag, and I'm hovering over things. Now, I've already gone back and checked the architectural model, the original model, and found out that they indeed have rooms set up in this project. So we should be getting some kind of an indication that there's a room. So there's another thing going on. Other things you can check, and this is, again, I'm glad this happened so we can review this. Other things you can check are to make sure, and we can't do it there, we have to do it in our view template, make sure that room tags are also enabled. That's the annotation portion of the room tag. Down here, make sure that room tags are enabled. We're good there in our model. Let's go to the Revit link. Make sure that rooms, remember we're in custom, and we are going to the model to make sure the rooms are enabled in the architectural link. Rooms are good there. And let's check the annotation. Make sure room tags, we have a lot of places to check here. Make sure the room tags are good there. So all of that stuff is enabled, and we still cannot get to room tags. There's an obscure issue here with this linked architectural file, and it comes down to kind of a more advanced topic that we usually don't cover till much later in a lesson, but it's called phases. Revit has built-in project phases, so that what I mean is phases in time, where you can have an existing point in time where you show maybe it's a remodel project and you have an existing portion of the building that's only half of the building. And then you have new construction, which is this wing coming out. And you can have those in different phases so that they can be turned on and off. Down here at the bottom of this view is the phase filter. And it's grayed out because in the template we says we want to show all phases and which phase are we currently modeling in, the new construction phase, because the existing would be nothing. This is a brand new building. So that seems okay. But what we need to do is look at the phasing of this model. Now, the way you do that is click on the model. I've got this set up here so that I can select it. Click on the model, and there we have clicked on the link. Now, we need to go into it's a type thing, a type parameter. We need to go into the types. And clear down at the bottom, there's Other, Phase Mapping. Again, this is advanced. Go into the phase mapping. Now, if you had a project where you had a remodel and there was an existing phase and a new phase, and maybe there was a phase 2, phase 3, you would need to map our model to match the architect's model. Why would their model have phases? Well, look at this. Our phases are existing and new, the standard out-of-the-box phases. The architectural link has existing and then one called learning content. So these don't match. We're looking at a learning content phase, which because this architectural model was set up for trying to teach how to do things, they had looks like here, they had a separate phase called learning content, which had, I don't know if you recall when we looked at the model, but it had some question marks that you could click, things like that. So they put that on a whole separate phase. So they have existing working drawings phase and learning content phase. Well, my hunch is that the working drawing phase is what we want. Click match our new construction to their working drawing phase. Click OK. First of all, it's not so dim, so that acts more like normal, because usually we have to go in here and change this to a halftone. And the other thing is when I click on it, now I see these X's, and these X's indicate rooms. So the whole key here is that the architectural model phasing had this extra phase called learning phase, which did not have rooms in it that was linked. So that's a good key for any future projects. If you have trouble with room names, things like that, check the phasing. So let's move on now that we have that fixed. So back up to room tag. Now, as we hover over a room, you will see they work. So we can put kitchen, dining. This whole area is kitchen, dining, all one area. We can put this somewhere where it mostly will be out of the way. We can always move it. That's the joy of having our own room tags, is we can move them around. And we need them typically in different places for a power plan as we would in a lighting plan. So let's get these in here. It gives you a name and a room number. And that can be controlled. If you click on there, over here, there's two different room tags built into Revit. Room tag and then a room tag with area. So if you're looking for some areas, and typically residential load summaries are handled a lot by area. So we may need that later. But right now, we're just going to tag it without the area, just to get the name in here. And this is a hall, and they don't have the stairs tagged separately, which is fine. This is the living area. So second floor power, same thing. Go to room tag. Now, you can also go to tag all and click room tags down here and see what happens. And it puts them all in for you. And then you can move them around to suit you. But that's kind of a shortcut there. Now, some of these areas don't have rooms, like this deck and this side out here. So if we want to label, we can just use text for those. But I would recommend doing the same for the lighting when we get to the lighting plan. But for now, we're good with power. So we have that done. Now we can deal with this halftone issue because this is fairly dark. And we do that in our view template. Let us go to our Revit link, and there we can apply the halftone. I also like to make it an underlay, which just means that if you think of it as layers, we want the architectural plan to be behind or under our line work. So the architectural doesn't obscure our devices in our line work. So what we want to do next now is to actually let's get to do some electrical stuff finally. We want to get some receptacles and power connections into this model. Like I said before, we're going to try to use as much of the out-of-the-box Revit families as we can, because I know customizing families is an advanced topic, and many of you aren't ready for that yet. You're just learning how to do this, and so I'm going to try to do this out of the box as much as I can to minimize the learning curve of getting things started. So let's see what we have in our model right now for families. Down here under electrical fixtures, families electrical fixtures, we have a duplex receptacle, and looks like we have already brought in a special purpose receptacle. Now, if you don't have that, we can bring in some more families. So a standard duplex, let's look at that. And we can just drag one in. You can also go up here to the systems menu and find the electrical pieces here. You can go to device and you can go down to electrical fixtures and you can click on that, and then it will give you a drop down that you can click and find the receptacles that way. That's one way to do it. I like using this project browser as kind of an old school tool palette. So I just drag those in from here. Another way you can do it is you can create a separate plan that has all of these in it, and you can just create similar from there. There's a number of ways to do this, but let's just do this. We're going to drag it in. Now you'll see that I can't just place this anywhere. It is a face hosted family. So it wants me to place this on a face. Now what's funny is it considers a grid line as a face, so that will kind of mess you up, especially somewhere like here where you have a grid line right along an actual piece of wall or cabinetry. So that will mess you up. But let's find a clean wall right here. So if we get close to that, now this receptacle is set up for the two lines hitting the wall. Some other receptacles are turned around. I've even seen receptacles that was just a circle with two lines in the middle and no lines extending from it. So whatever symbol you're used to, if you're trying to use out of the box, this is the one you get. So right there, it will let me place that. If I go too far, it tries to flip it around to other things. So you have to get a little careful to get that guy right there and click it, and there it is. Now a question mark popped up just because this receptacle has the opportunity to put some kind of a label in here. But when you escape out, that's what you get. So I should say, since we're doing kind of a residential plan here, there's a lot of code implications to residential receptacles. In fact, there's more code implications to residential than there is for commercial. So it's a much tighter code, and it's there for safety. We don't want people running extension cords across their room to power things, or through doorways or across doorways, things like that. So I recommend studying up on code section at least 210.52. I'm not doing a code class here. There's plenty of other places on YouTube you can find things, and on the internet, such as Mike Holt is a great code resource. He's been doing it for decades. And a great resource I found to study up on a lot of code issues is also Ryan Jackson. I'll put a link to his YouTube channel down below in the description, and you can check it out. He has a 3-part series specifically on residential code interpretations for receptacle locations and circuits that I find very helpful, and our firm uses that for a lot of reference as well. So shout out to Ryan. But I'm going to try to hit the major points of this, and I may miss a few, but I want to teach you at least the basic steps for getting receptacles into your projects and getting them circuited up. So we're going to follow the typical, what they call the 6-foot, 12-foot rule, which is where when you need a receptacle within 6 feet of the end of a wall, and you can't have more than 12 feet between them, such that a 6-foot cord along that wall can reach anywhere. That's kind of the basic rule. Then when you get in the kitchen, you've got receptacles needed above the counters. You've got receptacles that you need for the appliances, receptacles on islands and peninsulas, things like that. So we're going to try to hit as much of that as we can to get things laid out. So this is just a standard receptacle, 120 volt. Let's look at that. Edit. It's a voltage of 120, load classification. Now this is used mainly in commercial work where we need these loads to be classified by what they're used for, by the load, so that an appropriate demand factor, a calculation factor, can be applied to it. Some things need a 125% demand factor, like lighting. Other things need less. So that's under load classification. And you can see here, I'm not there, but right here, you get the list of load classifications that are built into Revit. So there's a lot of them. We've got clothes dryers and ranges, existing loads, equipment, elevators, heating, all kinds of lighting. So whether you have a different demand factor for this or not, you can still divide things up by load types to help you get an idea for how much load you have of each type. And that will show up in the panel schedules that we do. Again, this is residential, and we're kind of doing a hybrid using commercial calculations right now just to demonstrate how this works. So we're just going to leave this as a receptacle. And then over here, you'll see it says demand factor. Well, it gets confusing because the demand factor has the same name. It's called receptacle, and here's similar demand factors for these load classifications. Very rarely are they a different name. But what happens is in the receptacle, if you look at the details of it, there is a calculation going on in here. And this can be customized for other types of loads, but the basic idea is the calculation is by load, not by quantity. And following code rules, it's the first 10,000, first 10 kilowatts or kVA is 100% of that load. And then anything above 10 kVA is only 50%. And that's based again on the NEC. But that is done here for a number of different kinds of loads. So that luckily is already done for you in Revit. So we're just going to let that be with the demand factor of receptacle, load classification receptacle. We just want to briefly cover that is all variable in here. 120 volt. And you'll notice that there's no option here for a multi-pole like a 240 volt outlet. This is strictly a single pole 120 volt, which is great for this receptacle. Another thing I want to mention is you didn't see me do it because I did it in between episode 1 and 2, but I changed the scale of my drawing to 1/4 inch. You look down here, 1/4 inch, because this will be detailed enough where 1/4 inch will be nice. I could just enlarge the kitchen at 1/4 inch, but if we look at the size of this building and we kind of cheat and look at the size of the sheet, we find that it fits on there. So I only did it on this one view template and I did not carry it through. So let us just review how to do that. As you can see, my name of my view template still says 1/8 inch, so I need to fix that. But what I did is I went in here and I go here and I just simply changed the scale to 1/4 inch. And what I want to do is I want to rename this to make it the right name, just so that doesn't confuse us. And we'll do the same with the lighting. Let's jump into lighting, do that right now. See, it's still at 1/8 inch. So let's go here, simply change the scale to 1/4 inch. And let us rename it to 1/4 inch. There we go. Now that will affect the size of all of our symbols. So there we go. That's why the symbols aren't too huge. But the next thing I'd like to look at is these symbols don't really pop out of the plan. They're kind of just fading away as far as line type goes. They're very thin. Even the architect is thicker. We need to stand out more than the architect, of course. So the way we can do that, this is a symbol which ends up being a generic annotation category. Now, custom symbols that we make, typically we try to change that line type so that if we change the generic annotation in here, we're not changing the generic annotation for everybody. But let's just change the generic annotation line weight here. And the way we do that is we go up to Manage and Object Styles over here on the left. Object Styles. This is where you can get to the line weight of these categories. You can change colors, line patterns, things like that too. We need to change the size of the lines for the symbols. So we want to just go down to annotations. We want to go down to generic annotation. Generic annotations. And right now it's set for 1, which is the smallest line type. I like to punch these up to about 4. And I'll leave it black and solid. So that, as you can see, it makes it nice and thick, and it stands out a little better when we print it. So there, I think we're ready to send these around. I'm going to start with this room, which is we've got the kitchen, and this is a dining area. We're going to call this kind of a kitchen island, which isn't exactly against the wall, but it's close enough where I would think that an inspector, someone reviewing this, analyzing this, would say that this is not an accessible portion. We can't get back here to plug things in. And this is a permanently mounted cabinet. If this was just something on wheels, it'd be different. But this is permanently mounted cabinet, so I'm going to consider this all part of the wall, not behind it. So we're going to start at this edge, and the basic idea is to be not more than 6 feet away from the end of this wall. Well, how do you measure that? Well, you can start using dimensions if you want, but then there's nothing left to dimension it to. We can dimension it from here to our receptacle, and then you can move the receptacle around if you want to get that. That's one way to do it. So that's under 6 feet. Give it a little extra room. I don't like to be right on the edge. Another way you can do it let me get out of that, is you can simply go to an annotate and just draw a detail line. And so I will typically just draw a detail line and I'll come out, 5, 6, 5, 9, something like that to give myself an idea. And then I'll place a receptacle. So that will put the receptacle not further than 6 feet. Now, the next thing is, what am I mounting this to? I've got it on a wall, but what is this thing here? So let's go ahead now and try draw a section. Double click it. Now we're looking at that south wall, right in the middle of the cabinet. Now this is where you may want to change the view from electrical to what we call coordination. That will change the look of it. So it looks to me like we have window, see the glazing, we have window all the way to the floor along this. So that's going to be fun for our receptacles. So that's what I was afraid of, is that we have window all along this entire living space. Well, it looks like the owner of this building gets to invest in some floor outlets. The other thing you can do is you can hang an outlet from the ceiling on a cord, but I don't think that's going to be the preferred option here. So we are going to be getting into floor outlets. So now what do we have for floor outlets? Let's go up to the insert, and right here you can load a family from your network, from your local hard drive, wherever, or you can jump over here to load Autodesk family from the cloud. So this will link us to Autodesk's families. They have quite a bit here, and this used to get loaded onto your computer in previous versions of Revit, but now it's just online. So let's go to electrical. Now, I covered a lot of this in my other video, which I'll link above, which covers a lot of the out-of-the-box content you can get from Autodesk. And I covered that there's an architectural tab, electrical panels, there's a floor box, outlets, things. Warning against using architectural families, they do not typically have electrical connectors built in, so we can't connect them to our circuits. They are purely for visual. So let's get back out of there. We want the MEP type of families. Now we have standalone connectors. If we want to just connect something and not actually place a physical model, we may use those later. And then we have power, and this just narrows down the search. So we have appliances, fans, hair dryers, hand dryers, heaters. We may need fans for our mechanical equipment. But for now, we're looking at terminals, which they call receptacles, devices, things like that. So we have receptacle countertop, disconnect, double pole, duplex receptacle, top switched, emergency switch, high voltage. Do we have a floor box? It looks like we do not have a floor receptacle. We can see if the architectural floor receptacle actually has power. Let's load that and see what happens. Now, where is it? Let's see. Outlet floor. Well, because it came into electrical fixtures, this might be promising. And there, let's us put it on the floor. We click on it, you get no power connection. That was my fear. And you go to edit type, there's no electrical connection. Now this may be an opportunity to actually edit a family. Either way, to get a floor box, we may have to edit some family. So we can either edit this architectural family and simply add an electrical connector, which I think may be the chosen route, or we can create one from scratch. That's much more advanced. I think what we'll do is we will eventually just edit this floor box to have our electrical connector. For now, we're just showing receptacles, so we're just going to leave it as is. So we can get rid of that guy and put this one in instead. So there's a floor box. If you hit space, the number of times it rotates it. And it has to be, by code, within 18 inches of the wall. So we'll just put it there for now. This is just, as we know, diagrammatic. We're not dimensioning these. A lot of times an architect will come in now and dimension this for us. Let's go to the next one and keep moving along. In general, we're going to be measuring not more than 12 feet along here. I don't see any operable doors out of this first floor, so we don't need to worry about watching out for doors. So we're going to go all the way around this with our receptacles. So I'll end up speeding this up so you don't have to watch every measurement. but I do my typical, let's measure 12 feet. Let's go to about 11. And I can now just copy this. And then I have to go around the corner from the wall. So I'm here about 3 feet. So I have another 9 feet I can go. So let's go about 8.5 to be safe. Now we get to the hallway. There's a different code rule for a hall, in that if the hall is longer than 10 feet, you need a receptacle. So we know we need at least one receptacle in here. I like to go above and beyond sometimes, just because I've seen halls done so poorly. I'm going to copy this guy 12 feet, roughly here. We can use a standard receptacle now that we actually have a wall. So let's drag that back in the duplex standard and get that in here. We can center it on this wall. Again, these are all design decisions that you'll have to make. There, so we have receptacle, receptacle, there. That should cover that area. Now, these, as we saw in the architectural model when we looked at episode 1, click on it. For a linked model, I'm just hovering over it and hitting tab to get to it. And eventually you get there, and then you can see that this is, and it doesn't drop down, but it's a piece of furniture, so it is not a built-in cabinet that I need to worry about. So we got that. Now let's work on the kitchen. Now kitchens are tricky because we don't always know where the appliances are. Even the architectural plan that we looked at did not point to things and call them out. Some architects will do that, and I think that plan may, not be completely ready for bidding or construction. So there's a few things missing. So we will have to do our best here. It looks like if we hover over it, we get a little bit of note. If you read that whole pop-up there without clicking it, generic models, Mealy induction cooktop. So that's a cooktop. We need a receptacle for that cooktop. Now, we don't know the electrical specs for that cooktop. We don't know if it's a 120 volt, a 240 volt. Is it, 30 amp, 50 amp, what is it? So you may need to get cut sheets from your architect. You may have to go out and find it yourself based on a model number. For my purposes, right now, we're going to assume that we looked it up and found out that it is just a 30 amp 2-pole cooktop. So a 30 amp 240, we're going to say that's what we looked up. Now, how do we get a 30 amp 240 volt outlet in here? I'd already downloaded a special purpose receptacle. That's from that Autodesk site. And let's see what that does. Drag it in, and you can see it's trying to latch onto things, but it is a face-hosted receptacle as well. And we're eventually going to mount this to this back wall of this kitchen counter. So right there, let's click on that. Let's see what that is. It's surely a different symbol, and comes in at 1'6". We can leave that there. It's going to be behind. But what is it electrically? It says 120 volt, 180 VA, which is kind of a standard receptacle load. It's single pole only. There's no choice for 2-pole. So this is just a standard receptacle that with a different look. Now we need to find a receptacle that we can make 2-pole 240 volt. So that's not it. What do we have? Load from Autodesk. And we're going to go get away from this architectural because, as we saw, it doesn't have connections. MEP, electric power, terminals. We don't know what a clean receptacle is. Countertop, we can look at that. And a double pole switch, a duplex outlet we already have. This is a duplex outlet, top switched. High voltage receptacle, let's try that one. And eventually one of these switches. Quad receptacle. Here's a 220 volt receptacle. That might be promising. We'll have to see if it's 2-pole though. So we already have special purpose. So let's bring those in. So we simply bring those in and they will populate over here in our project browser under electrical fixtures. So let's look at this 220 volt receptacle, see what's going on here. pull that in, and it's got a nice different symbol. And sometimes you find there's something there in the model that causes this. It may be a column, who knows what it is. So you may have to find somewhere else to do this and then drag it over. Sometimes I end up putting a receptacle here, dragging it in. Let's look at it. 220 volt single. Well, that's more like, I would say, like a European type of connector that's just line to neutral, single pole, but higher voltage. So I think that's what that is. And we cannot change that. It's hard coded into that electrical connector. So again, this doesn't work. I do like the symbol. So now we're into a high voltage receptacle. Let's try that. It looks like a standard receptacle as far as the symbol. They've filled in the middle, which for our firm means above the counter standard receptacle. So here we have a symbol issue that we have to deal with. If we're going to live with Revit built-in, we're going to have to live with their symbology. And we can just call this out with a note. But let's take a look at the electrical. This is looking better. 240 volt, 2-pole. See, the number of poles is a parameter that we can change. So we have access to this. Luckily, it's already set to 2. And it's 240 volt, which is what we want, line to line. And then the load of this, we decided that if we're using a 30 amp outlet, well, 30 amps at 240 is like 7 kW. Let's say that this thing is, we found out this is a 5 kW, more like a dryer, because it's just a cooktop. So we'll say it's 5 kW. So now we have our cooktop. Now, as far as tagging this, we would need a tag that reflects a parameter within this. And let's see what we have for tag for receptacles. Question mark. Let's see what that is. This is a electrical device panel tag. Well, we don't have it assigned to a panel. And then we also have an electrical device circuit. So we can either tag the panel or the circuit. It's all we get out of the box to do this. Now we can look at other tags in the load from Autodesk. And if we go to all results up here, annotations, there's lots and lots of tags. So electrical tags, annotations, where's our tags? Down at the bottom, we have wire tag and wire tag panel with panel and circuits. Well, we may want that. Let's load that one. But let's see if we have anything about, we have conduit, capture, conduit, tick marks. If we have anything for electrical equipment, let's look at equipment. Electrical equipment tag, electrical equipment type. That's equipment, not fixtures. Electrical device circuit. Electrical device panel. So device circuit, device panel are what we already have. Now here they're calling it device, not fixture. Electrical equipment tag. Here's an electrical fixture tag. So we don't have a tag that will tell us anything about that receptacle. So we're just going to have to tag this with a text. So we'll just call this cooktop. And we're using the built-in 3/32 aerial. And then we can extend from here, click on it, and up here we can get to the leaders. So we can use a curved leader. Architects use those. I like to use this one. Nice straight. We've got the shoulder there. So something like that. That's the cooktop. Now, what else do we have for kitchen equipment? I like to pull this section, now that I have, up to here so I can kind of treat it as an elevation. Now, one thing about a section is you'll see this dashed line down here. That indicates the extent of the section. We can pull the sides in, and we can pull how far in it sees in the section. So I'm going to pull this in so that I only see inside the house. Look at this section. Well, not much to see. Now there's this up here, which is interesting. Let's see if we can, what is that? Built-in range hood. Well, that's good to know. We have a hood. So we'll need to connect that as well. And then what else do we have down here? There's our cooktop. I don't see any other appliances shown. So we will just make sure we get the hood. Now, how can we show the hood? We didn't bring in the motor connection, which I need to do. So let's go back to that load family. We're going to be in here a lot. We'll go to MEP, electrical MEP. And we're going to go to appliances. Let's bring this fan in. We don't need hairdryer, hand dryer. Let's bring the fan in, and that may give us what we need to hook up the hood. Now, again, this looks to be a face-based family, so it's looking for a wall or a surface to mount. We're going to mount it on this surface here, right there, and that's their symbol. So you get what they give you. I use a different kind of symbol, a circle with little wings on it for a motor, but this will work. And let's see if it has the proper connections. Right now it's a single pole. It does have multi-pole, so we can use this for a 240 volt equipment if we need to. Maybe we have a condensing unit or something outside that we need to hook up. But right now, and let's change this to, we typically do a 120 volt nominal connection instead of 115. This is set up load classification as an appliance dwelling unit. Again, we're going to be calculating this project like it's a commercial project, just for demonstration of a commercial job, not using the residential. We can probably do it both ways just to show the difference. But for a commercial, we would apply something like a motor to this. So I'm just going to call this motor. Other times you can call this an HVAC. And for exhaust fans, things like that, I like to call it HVAC, but I think this is not specifically HVAC. This is more of just a motor. And the demand factor for a motor, just to show you how that works, 125% for the first one, and then 100% for any more attached to this circuit. So that's good. And then our load on this, you know, we would have to look at equipment cut sheets to figure out the load on this. It's probably going to be a very small fan. I'm going to give it 100 watts. So there's that. And we can, again, we don't have an equipment tag made. It just tells circuits, not type. So we're going to have to use dumb text tag. Again, another reason for having some custom content is to get tags that actually tag, for example, the type mark of this. There's a hood. And then the other things we want to hook up here are what's on this other cabinet. So let's drop another section. And I'm going through this detailed piece by piece just for instructional purposes. If you want, go ahead and scrub through this and get to something more exciting. I knew this would be like this, showing every step of the way. So, tab over that, it's a dishwasher. Tab over that, it's just a sink. Okay, that's just the hardware for the sink. What's that? Someone left a cup. It's a vase. Okay, so we have a dishwasher and a sink. So we're going to assume the sink has a disposal. Now, these are all things that you can coordinate with your architect, or if you have a, plumbing designer, HVAC designer, things like that, kitchen consultant, you can do all the consultation with them to figure this out. I'm just going to show you what happens once we, if we knew what the loads were. So here's the dishwasher, kind of. Now, the dishwasher just gets a receptacle underneath the counter. So we need our standard receptacle. I can go down here and find it, or I can also find the one I already have, right-click, create similar, and put that guy down here. Now I want it to be on that cabinet there. Now this also assumes that this cabinet has a back wall deep enough for receptacles. So now I'm under the counter here, so it may not be an issue. Now when I get above the counter, that might be an issue. We're going to assume that this will get adjusted to be deep enough for a box. We want this to be a special load, not just a standard receptacle. So I'm going to call this a dishwasher. Now the way I do that is go over to Edit Type, because right now I just have a standard. I can go Edit Type, and I want to duplicate this and give it a new name. I'm going to call this dishwasher. I do this, created a separate type so that I can modify some of these type parameters. I want to change the load. I want to make this 500 watts for a dishwasher. Load classification. I can leave it as receptacle, but I'm going to call this equipment. And what's the demand factor on equipment? It's just 100%, which is fine. It's not on full time. And it's 120 volt. So now I have a receptacle. Now, when I connect this up to my panel, it will use the 500 watt load, 500 VA load, not the standard 180. So that's why it's separate. And again, we want to put some kind of a label on this. Won't be a smart tag. I use all caps. You can do what you like there. In commercial work, this is how I typically work. So there's the dishwasher. And then we also want to get a disposal down here. So let's do this again. We're creating similar from here, the standard. Get that here, and we'll call that disposal. Again, let's edit that and call it a different type. Disposal. And, you know, some of these can get pretty big. I've seen some that are half horsepower, 3/4 horsepower, pretty good size. So we're going to get it up there. Let's put it up around 800 VA. And we'll call that equipment also. $120 volt. So we're assigning separate loads to all these different kinds of appliances. Again, treating it like a commercial project. We'll just call this a small commercial project that looks like a house. So we have those appliances. Now we're going to finish the rest of the appliances. I think we have some stuff over here. Again, we can move this section over to that wall. And it shouldn't matter that I look through the wall here because I can change it to a coordination view, which acts more like an elevation. So there we go. That's nicely elevated. This guy looks like a refrigerator. Let's tab over it. And there he is, master cool, fridge freezer. This one ends up being a microwave, and this guy ends up being a oven. Okay, so refrigerator, again, you start looking at specs on these things. They typically, can be around 800 to 1,000 watts, depending on how big it is, maybe 1,200 watts. We're going to go with 800 for now. The oven, I'm going to figure at a full range power of a full 50 amp, 240 volt outlet for that guy. So that'd be more like an 8, 9 kW. And then this microwave, they're typically down around 1,200, 1,250, up to 1,500. So again, we are hooking up typical appliances to typical loads. It's never exact, because people can change these out in the future. I'm sure you've changed out your oven or your dishwasher at home, possibly. So we just have to get close. Now, these guys are stacked, so we're going to have to show receptacles. If we show them stacked, they won't look right, so I typically show them side by side. There's a way to show them stacked by applying an offset, which we can show, for example. But what do we want to show here? Let's go to our refrigerator first. It's a standard 120 volt receptacle. And I'm going to show it connected back here on this back wall, back in here within the cabinetry. It may get, in reality, may be pulled out to a face here, but for our purposes, diagrammatically, this works. So we're going to have that attached to that wall like that. And a lot of people like to put refrigerator receptacles higher than like 12 inches or 18 inches above the floor. So we can say that too. So for example, we can here put a little plus 48 inches just to signify that if you want to put height. And let's make this a special type of receptacle. Duplicate that again. And refridge is enough. It is 120 volt. We'll call it equipment. And we'll give it a load of, let's go 1,200. This is a big refrigerator. That tagged with a dumb text. And then up here, these are one standard and one special. Our range is going to be this guy, the 240 volt outlet. So let's get that in there. Let's go here and call this range. We're going to make that more like a 9,000 VA. And we can call this electric range 3.5 to 8. We're close to 875. We can leave that there. How's that calculated? That's a commercial range type demand factor. So we are just going to leave it as equipment because I want it fully calculated. 2-pole 240. There we go. If anyone knows the joke, 240, 241, whatever it takes, let me know. So that's the range. And then the microwave, great, similar. Get that there. Now, like I was saying, I could stack these, and what I could do is I could take one of these and see this offset from host. There's two different things. There's an elevation from the level, and then there's an offset from the host. Now, the elevation we could also change for this microwave, put it up at 5 feet. This guy is going to be a duplicate type called microwave. We're going to put him clear up at 1500. Equipment 120 volt. And let's put that up. Well, that's default. Actual elevation is going to be at 5 feet. And that's the microwave. Get a tag on there. Get a leader on there. Okay, now let's go back and fix this cooktop that I failed to name properly. We can just rename this now to cooktop. So that looks like our kitchen equipment is all in. Now we need to fill in with the rest of the receptacles that are required. Again, look at the NEC, you'll see that there's requirements for how many receptacles, and then when we get to circuiting, there's requirements for how they get circuited. For now, we're just going to show receptacles. The basic rule is, it's similar to the 6-foot, 12-foot rule. It's more of a 2-foot, 4-foot rule. You have to be within 2 feet of the end of a countertop, and then not more than 4 feet between them. And anything that serves a countertop has to be ground fault, GFCI protected, things like that. And you can indicate that on here if you want. Sometimes people just rely on the electrician to follow the codes when they install those to be the type. So right now we're just going to show these as receptacles and let the GFCI and furthermore tamper resistant, arc fault, things like that be more of a specification driven, things like that for now. We're mainly looking at the circuiting aspects of this. So let's get some more receptacles. Now I typically use this for a countertop receptacle. What do they have for countertop receptacle? They use the CTR. Okay, we'll use what REVIT says. We're going to go with the CTR. And we need to be within 2 feet of the end of that cabinet. 2 feet's right there, so we'll stop where we are right there. And let's get this copied over at not more than 4 feet, which looks good. We want to be a little bit away from the sink. So I think a couple receptacles here will do the trick. Now this guy's underneath, but we still need receptacles on top. So let's mimic what we have here. We have one there and then one within 2 feet of there. And back to the microwave. I was trying to show some offset and I forgot. So we can offset it. Let's go 2 feet. And you can see it pops it out from the wall so that I could actually stack these on top of each other graphically, but the receptacle is still on the wall at the height. So we can try that for now. That's one way to get things lined up properly in 3D, but not be obscured in 2D. And now let's finish up this countertop down here. We're going to mirror what we did up there. It's a very similar layout. And 2 feet and 4 feet. And again, we just get close. We make sure we have the right number of receptacles. Architects will often on their plans, their architectural plans, might do some elevations with some dimensions because they get picky about such things, which is good. And that does that. Now let's go into the mechanical room. Let's say we've talked to our mechanical designer and they've decided that they're going to have a furnace in here. So it's just a 120 volt, 20 amp circuit, they said. Create similar for this fan, and it's hosted, so we have to find a wall, put it on the back wall. We will call this, they're calling it the furnace. And we're going to call that one actually HVAC, just so it schedules separate. And this guy is going to be a full 1500 watts on a full 20 amp circuit, not a 15 amp circuit. That's the other thing we'll deal with is residentially, you'll see a lot of 15 amp circuits. So we'll go 20 amp there. And in the bathroom, we want, it doesn't show the sink. One thing you can check to make sure is that we have plumbing fixtures turned on in our model. And go down here to plumbing fixtures is turned off. Try that. That's in our model. We also need to make sure that plumbing fixtures are turned on in the linked architectural model. Plumbing fixtures are off. Now, why that toilet showed, it must not be a plumbing fixture category. There's the sink. This guy is a generic model. That's why it's a different category. It's not a toilet category. Okay, so now we have the sink. I like to get the receptacle either here on this side of the sink or on the other wall. We just have to be within like 3 feet of the sink. So we will get, now I call it above counter mounted because it's high. So we'll use this symbol right there. It kind of overlaps the sink. And this is one reason I don't use labels built into receptacles is because they're turned upside down. I typically will just show receptacle, and I have a different symbol, but if I need to add a label, I will just put it as text. Now the laundry. I think we already looked at these, and the architectural model determined that that's the washer, and this is the dryer. Now washing machine, gets a standard 120 volt receptacle. So we can use this guy. Put that back here for the washing machine. Again, we hit something, so we want to find clean wall and then drag it in. That's for the washer, and it's going to be, again, residentially, codes say we use a 1500 watt circuit. For the laundry room, washer itself, and other things in the laundry room. And then we need to have also a separate dryer circuit. So this guy, we're just going to call, again, a hybrid of load styles. Duplicate. We'll just call it laundry. And do we even have a laundry? We don't have a separate laundry. So we'll just call it equipment. And our load, we're going to put at 1500. Again, we're going to calculate this like a commercial project. Now the dryer is a 240 volt, 30 amp outlet typically. So we need another 240 volt outlet receptacle right there. And we will call this guy, duplicate, dryer. 240 volt 2 pole. And we're going to call this electric clothes dryer. Look at that. What do they have for a demand factor on this? Less than 4 or less. Less than or equal 4 or less is 100%. So that works. Again, commercially, if you have a lot of them, you get some diversity. And this guy is also a 5,000 watt load for that 30 amp outlet. And let us put some text on these. Washer and dryer. We can move our tag around, which is nice. Washer and dryer. Now, we may also like another receptacle in here for an iron. So let's go ahead and do that with just a standard receptacle and get that. Looks like, now that wouldn't be a window, maybe a very high window. So I'll put it on the wall. Now what's happening is I've got a grid line right next to my wall. So the receptacle is trying to grab onto that grid line. So what I need to do is make sure I'm hitting the wall. Now, when things are stacked in Revit, remember you use the tab key to drill down into it. So if I hover here, hit tab, you see it pop up there. Now it's actually using the wall, not the grid line. So click on there, and I'm going to drag this underneath this window. So now we have a convenience receptacle in there as well. I think we've got this room taken care of for receptacles. One thing I haven't checked is to see if we have anything on the ceiling that needs power. We can check for that later. For now, we're going to look at the living room. And we've got some steps. These are steps because this, as you recall, is a sunken living room. It's about 2 feet deeper. So anything we put on the walls is going to be really kind of the wrong height if it's based on the level 1 height versus the level 1 living room height. So we're going to have to deal with that. I'll show you how we deal with that. We want to start our receptacles. We need something for the TV. Now we can just put a receptacle here. We have to be within 6 feet. I would say this is the end of the wall for this living room. So let's put a receptacle, create similar, on that wall. And within 6 feet. And it looks like we're good. Let's just check the distance here. Yeah, 5 feet, that works. Right now, this is hosted to the linked Revit model. It's hosted to level 1. That's up here, 2 feet higher than the level we need. Now, we can't host this to the level 1 living room because we did not copy that. If you go back to episode 1, we did not copy the architect's level 1 sunken living room into our model. So we actually need now to link that in so we can relate these receptacles to it. So how do we do that? We go back to an elevation or a section. We can do it right here in the section. You'll see our levels. And I'm going to grab my levels and grab it here, not at the circle, and then drag it out so I can see it. So we have living room, and let's change the scale list so we can actually see those. We want level 1 living room. We need that. So we can just copy this and draw over it, or we can do, again, copy monitor. That was under collaborate, copy monitor, select the link, hover over the linked Revit model, click that, copy. I don't need multiple this time. I just need one. And I can't get to it out here. I have to be here within my boundaries of this view. Click on level 1, and it's doing its thing. It's copying. Down here, processing. And then, since I don't have multiple, I don't need to finish there. I can just finish the copy. Now I have a copy of that living room, level 1 living room, and it put it in as feet and inches instead of metric. Drag it over so it lines up with that. Now I have level 1 living room that I can utilize in my model. So back to my plan, back to this receptacle, click on there. Now I can change the level to level 1 living room. And what I should have done is put my section down there. Let's drag this around. This is just so we're just using it for our purposes of design. So here we have our elevation of this wall. Now we can see our receptacles are still high, even though we associated them with the lower level. Well, the reason for that is, and let's look at this, just because we associated it with a different level doesn't move it. It just changes the dimension. So now it's elevated from the level by 3'3" and this crazy fraction of an inch. So it didn't move it. It just is hosted to a different level. So now we need to manually put this down. And I have these at the 1'6" dimension, like commercial ADA receptacles. Now, if we look at that section, we can see it's down here. So as I create new receptacles, I want to make sure I create it from this one, which is set up to be hosted to the lower level. So let us look at the rest of these. In this room, we have some more windows. Let's check and see if these are clear to the floor windows again. They are. So we're going to be doing some more floor boxes. This is wall. This may be window. Let's cut another section. Window all the way down to the floor. Okay, so that's what we have. Now this guy, just looking at this, we have doors, so we don't have to count the door as part of our distance. We can start at the edge of the door. And what do we have for a distance between these? We have 10 feet, which is less than 12. We can get away with a single receptacle here. Now this is, let's look at what this thing is. I think it's a fireplace. It is a fireplace hang. Not sure if this is going to be very accessible, but we'll put one here. I would say a fireplace is typically permanently mounted. So we may be best to go ahead and put receptacles and add additional receptacles on either side rather than hide it behind this guy. So I'm going to go that way. Now we need to get our floor box from up here, create similar, and we're going to have to relate that to this level. So turn it like that. We'll put it right here. And let's get that hosted to living room level. Now, because this is hosted to the floor surface, it automatically is still at 0. It wasn't wall hosted. And we can just copy this. If we're not putting something on a different level or something, we can just do a standard just copy. And it will still be hosted, and it's still at 0. I tend to use create similar a lot just to make sure that it hosts properly. So we've got that, and we have 5 more feet, so we can go 7, but let's keep it a little bit short. Put that guy there. Now this is again where we have a grid line in the way of our wall. So hover over the grid line, hit tab. Now we are on the wall surface. And we want to copy this not more than 12 feet away. Wrong, we need floor boxes. So 11.6 is a good, careful dimension. Get this down here. And if we want, we can line that up with that mullion and still be within our 12 feet. And we can move this a little bit because it was 11.6. But we're getting down to the inch here. And then what do we have from here? We can go 11.6 to that. And that truly is a wall. So we can create that on the wall. Not the, let's tab out. There we go. And how are we doing for distance here? We may need another receptacle. If it's further than 6 feet, it is 7'11". Yes, we do. So get that down, and I don't like to put it right at the corner. Let's get a couple feet in so it's actually useful. But that wall needs 2. Now we can just mirror what we've done over here. Now, are we on the grid? It looks like it's not trying to hit the grid. So we're okay there. We'll put a floor there. Let's get another. Now this is a different layout. I'd go 6 feet from this step. Right at the edge. I think that will still give us 12 feet. And get this floor receptacle over here. So that does the living room. This is all just furniture. Now, if we want to try to, put some floor receptacles in here for tables and such, we sure can. And, we may talk to the owner or architect and see if that's something that's desirable. But for now, we'll do the minimum. The other thing is, do we want anything outside? Do we have any outside appliances? And typically outside appliances, are like gas. Commercially, we have to put in some interlocks and electrically controlled gas valves and some timers, things like that. But residentially, it's much more lenient as far as that goes on gas. So we may still want some receptacles outside for convenience, an exterior mounted light or something like that. So I'm going to at least get one receptacle out here. And tab for the purposes, and those would end up being weatherproof and GFI, and we can tag some of that stuff later, or again we can let some kind of a written specification do that, or let code drive that. And before we finish up, it just occurred to me that when I created this similar, I did not check to make sure that I put it at the level 1 living room. We're still at level 1 because this one was hosted to level 1 when I created similar. So a couple things we can do. We can either go through and change each of these to the proper level and change their height, or I can actually create a plan view at the lower level, model my elements from that plan view, and it will still be available in this plan view because it's all part of the model. So let me demonstrate that way to do it. So I think best practice here would be for us to go ahead and create a lower level floor plan. Now we go up to view, plan view, floor plan. We don't have one created for level 1 living room yet. And this is just a standard floor plan. Say okay. And we need to give this the proper view template, because view template also arranges it into our project browser under the proper headings, disciplines, subdisciplines. So let's go to our power plan, 1/4 inch. And we don't need to worry so much about cropping this and all of that, because this is not going to be what I would call a production view. It's not going to be a sheet view. It's just for placing. It's kind of a working drawing. So I'm going to call this, just to get it numbered here, let's just call it 3 lower living room working. So it's just we don't want to rename the level. So just lower level living room working view. So now what we can do is get rid of that. If we create similar now and put it in the same place we had it before, and we have to tab again. Now this guy is hosted to the level 1 living room at 1'6" above it, because that is our current work plane. So we would do the same here. Now this guy, because it hosts to the floor, it's a face-based hosted family. We can merely change it to the proper level and it is still at the floor. This guy, well, he will need a new one. So I'm going to delete these. And because we're on the same face, we're on the same wall, I can actually just do a regular old copy. And let's copy that one. And we can see that we're within 24 feet. Copy that and then get this guy down here. We already made sure this one was on the lower level. This one is on the lower level. These guys are on the wrong level, so let's get rid of those. This one needs to be moved. So again, this complicates things a little bit, makes it a little more tricky to have this different level, but it's a good exercise to understand how to deal with these different levels. So we're going to create similar roughly across from that one. And it should host to the level we are on. More copies. So this is finishing up this plan. And I would say the same thing with these exterior receptacles. We're on the same wall, so we can just copy. And actually, these are a code requirement to get receptacles out on a porch. So that's another reason to put these out here. So that takes care of the level issue. Now we want to go back to our actual first floor level to go back to the kitchen dining. And what I realize is that this back of this counter is actually going to be considered a wall space within here. So we are going to need to treat that just like a wall. So we need to be 6 feet from the end of this, wrap around the corner. So we can include the corner as part of the 6 feet. So we have a distance of just over 2 feet. So if we're within 3.5 feet from here, we should be good. So I'm going to put one right in front of this. This is just a stool that can be moved around. But let's go ahead and copy our receptacle to here. And again, here we are. Here's our grid line. The same old issue. Tab through that. And then let's copy this within 12 feet. And we're good there at this one. So that should cover us in this room. The only other space would be if we need one here in this kitchen. Lately, I've been just playing it safe and adding a few extra receptacles. I would rather have a little bit extra than, especially in the work where you do the design and someone else installs it. You hate to have all these change orders and things added later on. So I'm just going to put that in there to be safe. Now that guy wants to host on the back of that wall. See right there, it flips over. Here it doesn't. So again, there's something in the model that's invisible right now, but it is affecting where that receptacle gets hosted. So that can drive you nuts sometimes. So let's find a place that works and then drag it down. And that should cover us here. And that should complete this level. So I'm going to stop episode 2 right here with just getting level 1 receptacles and appliances connected. I think level 2 is going to be much faster because it is bedrooms and bathrooms. So until next time, thanks for watching.